Right. Question 1. Vectors. Show that the straight line with equation that meets the line passing through that, and find the point of intersection of these lines. Yeah. Well. Oh, yes. Yes. Have you swapped them to? Yeah. Swap them. Go for it. So we need to find the equation of this line, don't we? Now the line, of course, goes through. So the direction of the line, I'm going to call them points A and B. I don't know why. Would be minus that one plus that, or you bring it the other way around, which gives me minus 2, 1, minus 3. So our other equation is R equals, it goes through these 2 points, so we'll choose one of those as the point on the line. Plus, we've got 2 there, so let's use U.
It comes after T.
Oh, it does, doesn't it? Yeah. Okay. Minus 2, 1, minus 3. Good spot. Right. So we can put these 2 together. Now we need to show that the straight line meets the lines, show that they intersect. Oh, before we do that, we need to check, are they parallel?
It just says find the point of intersection.
They're not parallel, as minus 2, 1, minus 3
Alright.
is not equal to some constant times 1, 4, minus 2.
Do you lose mark if you didn't put that bit?
Probably not in this case, but it's always safe to put it in there, isn't it, just to make sure. Right, so we're looking for they intersect if 9, 7, 5 plus u times minus 2, 1, minus 3 equals 2 minus 3, 5, 3 plus t times 1, 4, minus 2. And then we just compare the coefficients of I, j and k. So we look at the I coefficients on both sides. No. So we have 9 minus 2u is 2 plus t. Look at the j's. And the k's. Bearing in mind that you may have slightly different equations to these, because you may have used a different point there, and you may have done your direction vector slightly differently. What have we got here? We've got that 2u plus t equals 7 out of that equation. We've got u minus 4t equals, why am I doing it this way around? Minus 10. Should we compare these two? Do I need to hurry up? Yeah,
yes,
okay.
You got like 5 minutes.
Oh, okay. Right, sorry. I'm going
You're
faster.
stalling.
I'm not. Oh, that's exciting, isn't it? 0. Right, so let's call these 1, 2 and 3. Equation 1 gives us that t equals 7 minus 2u, so sub that into equation 2. U minus 4 lots of 7 minus 2u is negative 10. 9u, is that right? Minus 28 is negative 10, so 9u, aha, is 18. U equals 2. We need to check that that fits the other equations. Well, the first one would give us t is 7 minus 2 times 2, which is 3. We now need to go to the equation we haven't worked with yet and check it's consistent. In equation 3, if u equals 2, we get 6 minus 2t is 0, which gives us t is 3, which is consistent. Therefore, they intersect. Great news. Did we have to find the point of intersection as well?
Yeah.
We did. So we go back and take, probably easiest to do it with the value of t that we got, which was 3 in the first equation, r equals 2 minus 3, 5, plus 3 lots of 1, 4 minus 2, which gives us the point 5, 9, and minus 1. And so intersect at,
Speed up.
speeding up, 5, 9, minus 1. we really should give our point as coordinates at the very end. Great. Any questions? No. Question 2. The equation of the curve is x cubed plus y cubed is 6xy. Find dy by dx. Well, this is that, remember the stuff we did about implicit differentiation? So we differentiate each term with respect to x. If we differentiate, we get 3x squared to start with, when we differentiate x cubed. We differentiate y cubed. Remember how we do this. We differentiate with respect to y, and times that by dy by dx. So this would be 3y squared dy by dx. And then the 6xy is a product. That's 6x times y. So it's the first times the derivative of the second, which would be dy by dx, plus the second y times the derivative of the first, which is 6. We now need to find what dy by dx is. We have dy by dx times 3y squared minus 6x. We take that over to this side. And over here we have 6y minus 3x squared. Taking 3x squared over. So, for 4 marks, whoops, our answer is dy by dx is 6y minus 3x squared over 3y squared minus 6x. Except, we've got loads of common factors in there, haven't we? 3 all the way through. So let's take out 3 as a common factor and divide top and bottom by 3 to get 2y minus x squared over y squared minus 2x. There's our answer. Show that the point. Now I'm sorry about the typing here, these were powers here. So that's 2 to the 4 thirds, 2 to the 5 thirds lies on the curve, and that dy by dx is 0 at this point. Okay? I don't really like this question. I think my instinct is I feel I want to sub one of them in and then solve it for the other one and do it that way, and that's a mathematically neater way. We would probably get away with just subbing them both in and showing that the two sides balance. So if we take the point that we got, which was 2 to the 4 thirds, 2 to the 5 thirds, and we sub that in, then that will give us x cubed plus y cubed is 2 to the 4 plus 2 to the 5, which is a number 48.
Yeah.
And 6xy would be 6 times 2 to the 4 thirds times 2 to the 5 thirds.
For 48, you've got
Which is 6 times 8, which is 48. So it is on the curve, and show that it's 0 at this point. Well, dy by dx is 0 if 2y minus x squared is 0. That's all that matters. So that's if 2 times 2 to the 5 thirds minus 2 to the 4 thirds squared. That does equal 0. Therefore, it's a stationary point. I feel I ought to have done more than that. I feel I ought to have solved something, but I think we get away with it. And point 3, part 2, again. The point AA, where A is greater than 0, lies on the curve. Find the value of A and the gradient of the curve at this point. Well, AA, that's the point where x equals y, isn't it? So if we sub in the point AA, then we've got a cubed plus y cubed equals 6xy, 6AA. So we've got 2a cubed is 6a squared. If we divide through by a, which we can do because it's bigger than 0, and divide through by 2, we get a equals 3. And the gradient at that point, dy by dx, would be, subbing x and y both equal to 3 into there, we get 2 3's minus 3 squared, divided by 3 squared minus, 2 3's. which I'm going to say is -1, unless I'm very much mistaken. And there we have it for 4 marks there. Great, sorry that was so quick, and that's maths.